Across the Rocky Mountain West, red hues dot the forest. But these aren't the colors of autumn. These trees are dying, under attack by an unseen adversary, the mountain pine beetle. Mountain pine beetles are native to western forests, and they've evolved with the lodgepole pine trees they infest. But in the last few years, warming temperatures have caused their numbers to surge. They're killing an unprecedented number of trees. Some say the swath of dead forest left behind sets the stage for another Rocky Mountain native, wildfire.
For a long time we thought that beetle-damaged forests were more likely to burn than green forests, and that's because they look much drier and you have this feeling that this is just a tinderbox ready to go.
But are these trees really more likely to burn? Forest ecologist Phil Townsend and his team are using NASA satellite imagery to find out. The Landsat satellites don't have high enough resolution to discern individual trees, but Landsat's special near-infrared sensor can detect areas of damaged forest. In this false color view, green means healthy forest. Green and red together means damaged trees mixed with healthy ones, possible beetle damage. Recently burned forest shows up as bright red. Landsat images let us study forest health across a large area, but each pixel captures almost 1,000 square meters of forest, covering lots of trees. So how can you be sure what's really going on inside a pixel? You've got to hit the ground and see. The team lays out transect tape to measure out points 30 meters apart, the area within a single Landsat pixel. Within this pixel zone, they get a close-up look at the health of each tree.
When we're in the forest conducting our research, we look for signs of beetle damage to the trees. The first and most obvious sign would be whether the tree has red needles or not. Well, that's a sign that the tree is dead, but it's not necessarily always caused by beetles. So we then look at the bark of the tree, and if we see pitch tubes, which are where beetles have attacked the tree, or exit holes, which are where the young beetles have emerged from the tree, then we know that there has been beetle damage.
Pitch tubes are holes bored by beetles. Living trees defend themselves from the beetles by streaming sticky resin from the wounds. But if enough beetles drill enough holes, the trees die. The research confirms that they're reading the Landsat data correctly. The target zones are, for the most part, killed by beetles. Next, they can compare those zones to areas burned by fire. And what they've discovered is surprising. Instead of creating a tinderbox ready to burn, the beetle-killed swaths appear to have little effect on fire. In fact, in some instances, they may even reduce the risk of severe fires.
Once those needles come off the tree, that fuel source isn't so much there, and so actually the beetle-damaged forest may be less susceptible to burning than a green forest, where you still have material, and during a drought this material may be very dry and be able to carry the fire from the surface up to the canopy.
The Landsat data, double-checked with on-the-ground observations, show us that things aren't always as they appear at first glance.
I think it's important for people not to assume that there are relationships between certain types of features out on the landscape. It's often much more complicated than we think. Oh, that forest has been damaged by beetles, it's more likely to burn. And that's why it's important to ask questions and to just not take everything as gospel truth, and to go out and actually do the research and see if what we think in our mind is actually what's happening on the ground.
While one mystery seems to be solved, another remains. Why are both mountain pine beetle numbers and fire risk on the rise? The answer may well be our changing climate. Cold winter nights kill beetle larvae. In the last decade, temperatures haven't dipped as low. More beetles are surviving to damage more forest. And fires take hold and spread faster in a warmer, drier climate.
The beetles and the fire may not directly be related to each other, but they might be each related to the change in the climate, and that's important to find out.